Welcome back. This module is about the problems blockchain can and cannot solve. It's like having a hammer and learning when and when not to use it. Some problems are tailor-made for blockchain-based solutions, and some may not be suited to them. But as with every new technology, we cannot today predict what new and exciting ways blockchain will be used. Remember, in 1991, the internet was used for email. Now we'll look at what it can do. Also, as we say, the future is not something to be predicted, it's something to be achieved. So maybe you'll be the one to achieve this new future. By the end of this session, you'll be able to identify the many real opportunities for blockchain technology. You'll consider various opportunities for blockchain within your chosen market segment. You'll learn how to use a decision matrix, which is a simple tool that will help you select the most promising idea to pursue for your final project. By the end of this week, you'll clarify the overarching purpose and specific objective of your project. You'll identify your target customer or audience, and you'll prepare a statement of need and a statement of benefit to include in your proposal. You may find it helpful to go back and review some of the topics we covered in previous courses within this specialization, including what is blockchain, blockchain design principles, implementation challenges, and opportunities for blockchain. To recap, blockchains hold promise to help overcome challenges like the lack of resilience, durability, trust, and privacy of our current system. So let's look at what blockchains can't yet solve. Let's also look at the new challenges they bring and the remaining challenges of distributed ledger technologies in general. Scalability is one of the most complex and controversial challenges of blockchain. The best known blockchain network, the Bitcoin blockchain, and those forked from it haven't yet resolved this issue. Other public blockchains, such as the Ethereum blockchain, also haven't resolved this issue. Even now, they process a low number of transactions compared to more centralized networks, such as the Visa credit card network. Bitcoin processes about 7 transactions per second, and Ethereum processes 25 in their current states. This latency or delay in confirming transactions comes from different factors. Some of them are artificial by design. Bitcoin's proof of work and distributed consensus requirements slow down the processing of transactions, but in exchange for greater security. Latency makes most blockchains in their current form not practical for some industrial and consumer environments. Imagine having to wait a minute for a light to turn on while the light bulb negotiates the purchase of electricity from a neighbor's solar panel. Latency comes with the lack of scalability. These are major concerns for many use cases, such as the Internet of Things, as described. The developer community is making efforts to address scalability and latency. Public blockchains like Ethereum and Bitcoin won't help out of the box, so the community is thinking about higher-level protocols and solutions. The idea of aggregating transactions is an interesting one. Several initiatives are looking at this sort of solution. The COCO framework batches transactions, so we can process about 1,600 transactions per second on top of the Ethereum network. Perhaps the best-known scaling solution is the Lightning Network, built on top of the Bitcoin blockchain, where transactions can be passed through each other in so-called state channels. This has the potential also to scale the Bitcoin network dramatically. Transaction costs are another issue. Fees for microtransactions can be high in public blockchains. The average rate for a $1 to $2 transaction on the Bitcoin blockchain was 38% in December of 2018, and it was 3% on Ethereum. So doing frequent microtransactions, like say uploading the new temperature value of a sensor, is unrealistic. And the processing power and time required to perform the encryption and confirm these transactions, plus the increasing storage needed to record the ledger, and we have systems with more limited uses. Regulatory uncertainty is also an open question. Entrepreneurs are often ahead of regulators, especially if they're creating new markets with unprecedented products and services. This results in legal gray areas. The European Union's General Data Protection Regulation, better known as GDPR, for example, provides the right to be forgotten. This means an individual can demand to have any data about him or her erased from the holdings of a data controller. The right to be forgotten is clearly problematic for blockchains, where transactions can be deleted by design. This might be the most striking example of how regulations are not quite ready for true distribution of power, where no central authority is accountable. But it's not the only issue. The next issue is interoperability. Blockchains have the potential for smart contracts and smart things to talk to one another, thing to thing, and not through large centralized platforms like Google or Uber. But for this distributed communication of information and value to work at scale, we need interoperability. Everything must communicate through some common set of protocols. It's far from a given in the blockchain ecosystem. New and incompatible blockchains appear all the time. We need convergence of standards if we want worldwide peer-to-peer and autonomous communication to flourish. Energy consumption is another issue. Not all blockchains are created equal when it comes to energy consumption. The most power-hungry ones rely on proof of work, so each unique Bitcoin transaction carries a large carbon footprint, even based on a conservative carbon emission factor. The pace of change presents challenges and opportunities. Smart contracts, smart cities, and autonomous processes need to rely on proven technologies to last for years without fundamental changes. Experts estimate we'll have to wait about a decade before distributed ledgers reach scalability and mass adoption. We're much more optimistic. That said, it's rare for a field of computer science to develop as quickly as blockchain has. The blend of advantages and challenges for distributed ledger technology means that the design choice is far from straightforward. A few criteria, like potentially better scalability, have yet to be proven, though a great deal of progress is being made. So instead, we should focus on the unique features of blockchain relevant to our use case. Consider 5 questions in particular. Number 1, do we need to rebuild trust? Number 2, do we need to conduct multi-party transactions without a costly middleman? Number 3, do we have a reason to distribute computational power? Number 4, do we need an application to run with no downtime or risk of censorship? And number 5, do we need to protect identity and privacy? If we answer yes to all 5 questions, then blockchain is the only solution. So by the end of this week, you'll be able to tell whether problems are well-suited or maybe not well-suited to blockchain-based solutions, at least today. Up next, you'll use a decision matrix to select the most promising of your ideas for your course project.